The telescope system that we're looking at here, we can also use to demonstrate some of the capabilities of APEX in terms of optical component design and reuse. In particular, for this design, we have our primary mirror, which is a parabolic surface shape, but we also have our secondary mirror, which has a hyperbolic surface shape. For optical systems, it's very important that when doing ray tracing, these types of surfaces be accurately modeled on an optical level, that is, on the order of nanometers and below. The necessary surface accuracy is often difficult to achieve in CAD programs for surfaces such as hyperbolics or higher order A-spheres. Within the APEX environment, we have our optical manager, and let me open that here. And what the optical manager allows us to do is provide catalogs of stock lenses from different optical vendors, but you also have the ability to create your own optical components. In this particular case, we've created a couple of lenses, and I'm going to take a look at the corrector, and we'll just edit that file so we can take a look at it. This is what's important about using the lens manager within APEX. The ability to define optical shapes of any conic, as well as having higher order aspheric coefficients, which are commonly used in many imaging type optical systems, as well as some illumination systems. By modeling the component within the lens manager, you are going to create an optically accurate definition of that surface. And more important, let me cancel out, once I've defined this component, it's available to me within my manager for me to use anytime. I can create any number of optical components within my manager, and I have the ability to categorize them in whatever way is most appropriate for my use. All right, so since I've already created the system, I'm just going to cancel out. But again, the lens manager is very efficient in allowing you to model any type of lens component. Now you might ask why I modeled my mirror, my secondary mirror, as a lens component. It is to allow me to get the exact shape necessary for this hyperbolic surface without having to go through any excess effort within the CAD environment. My corrector lens was also designed within my lens manager, and then I have a detector surface to get an idea of what the image quality, for example, would be for this system. And to do that, what I'm going to do is another ray trace. Right now, we're simply looking at a fan of rays, so a one-directional distribution of rays going through our system. We can see the rays would come in this direction, reflect off the primary mirror, reflect off the secondary mirror, travel through a hole within the primary mirror, then to my corrector lens and my detector. You'll also notice that the rays near the axis are blocked by the back surface of the secondary mirror. So we're going to see that not all of our rays will make it to the detector. And to get a good idea that indeed I have the components in place, because as we zoom in here near the detector, we can indeed see that our light is coming to an image at that location. But for real analysis, I'm going to need to look at a lot more rays going through my system. So what I'm going to do is simply come to my optics manager and modify my source to trace more rays, and maybe in this case I'll do a 21 by 21 grid of rays. Just click on OK, and let's perform another ray trace. And again, we see the same behavior, but let's rotate it around. But this time we have a much larger distribution of rays covering the entire primary mirror. And we are still coming to a nice focus. These are simply showing our arrowheads on our detector surface. So now let's use APEX to do some analysis. And one thing I might be interested in is the RMS spot size on the detector. Let's zoom in on the detector to take a little better look and do some more analysis. So here we go. And now what I'm going to do is select this as the face to do my analysis. And the first thing I want to do is to look at some statistical data. So what I'm going to do is get some positional information. And what this is telling me is what the RMS spot size is and where the location of the centroid of that data is. And as you can see, all of my rays are coming to a focus almost at a point location. And now let's take a look at it in a little bit more graphical form. So what I'm going to do is, again, analyze this surface. And in this case, let's look at an area distribution. And we'll look at an irradiance plot as well as the spot's position, which is simply showing where the rays are. And just click on OK. And as we can see, again, we have a very, very small distribution of rays, much, much smaller than our detector. And here's what the spot looks like on this detector, but I'm simply going to zoom in a little bit to get a better view. And as you can see, we have our image. It is very, very small, on the order of, as we saw in the statistical information, a couple of microns across. And you also notice that we have this opening here, which are simply due to those rays that were blocked by the back of the secondary mirror. So we can use Apex for designing imaging systems as well as illumination systems. Now that we've verified the performance of the telescope, we could add in the mechanical structures, the spiders and other apertures, and we could do analysis on looking at stray light and other problems that can occur in these types of designs.